Lesson 9.1, Part B. Multiplying rational expressions. Now we have an example here of two fractions being multiplied. Now we can cancel vertically like we did on the last page, but we can also cancel diagonally if they have something in common. For example, I could say, you could do it the way they have here, which is to multiply across, so they would have had 20 over 6 times 15, and what's that? 2 is 30, 90. I think that's right. Yep, that looks good. Okay, so that's one way, and then they'd simplify from there. Here they wrote all of the prime factors, like I did at the very first screen. But you could also say, well, I know 5 goes into 5 once, 5 goes into 15 3 times, 2 goes into 4 twice, and 2 goes into 6 3 times. That would give you the same answer. Okay, so again, a couple different ways to get to the same result. But I want to make sure we know that we can cancel vertically and diagonally when we're multiplying. And the end result would just be top times top, bottom times bottom to get the new fraction. So here we have an example. I can multiply this out right away and take 8 times 7 and so on, x and y squared, and get an answer. Or I can simplify right now. So if I look at this, I can notice that 7 goes into 7 once, 7 goes into 21 3 times, 8 goes into 8 once, 8 goes into 16 twice. I have an x above. I'm going to take out one of the ones below, so it becomes a 2. I have y squared above, and that will cancel all of the y's below except one of them. And that will leave me with 1 times 1, so that's just going to be 1 on top. We have a 3y in the left one, and a 2x squared right here. And then we can just finish this off by saying 3 times 2 is 6. And put them in order, x squared, y. Now that's one way. Like I said, I could have multiplied the numerators and gotten a big number first and so on, but this is a little bit more efficient, I believe. Next question, same thing. 5 goes into 5 once, 5 goes into 10 twice. 3 goes into 3 once, 3 goes into 6 twice. Y above, y below. Up here we have y below and 2 above, so it takes out one of them. We have an x below, and I'll take out one of these x's. I have an x right here, so I can either take out one of this fraction or one of the other one. It's your choice, but I can only take out one of them. So I'm going to take out this one, so it's all gone, because there's one left there. That will give us 2 on the left one, that's the only thing left. A 2 on the right one, and x cubed y. On the bottom we just have 1 and 1 and a z, so just z. So that will give us 4x cubed y over z. Okay, and those are our two fractions. Division. Well, if you remember, you cannot divide fractions. Instead, they changed it from dividing a fraction to multiplying by its reciprocal. So 14/9 is the reciprocal of 9/14. So dividing by a fraction is the same as multiplying by its reciprocal, meaning the second fraction. A fraction divided by a fraction is the same as a fraction times the second fraction's reciprocal. So let's take a look. We have a division problem. Let's make that multiplication. We don't want to cancel yet because we could get confused with respect to what is diagonal, what's above, what's below. So let's fix that first. That will be our priority. So now we have 5a squared b cubed over 6xy. Now that it is being multiplied, I can start to simplify. 3 goes into 3 once. 3 goes into 6 twice. 5 goes into 5 once. 5 into 20 4 times. We have an a below and an a squared above, so it takes care of one of them. We have a b below and b to the third above, so that takes away one of them, so it's b squared. We have a y below and a y above, an x below and x squared above, so I'll take out one of them. That gives us an x from the left one, left fraction, and an a from the second one, and a b squared from the second one. On top, on the bottom we have just 4 and 2, so I'll make that 8 right away. Make it appropriate and in alphabetical order. We'll change that to a b squared x over 8. Okay. Now let's look at monomials or binomials and trinomials. Okay, well notice it's division. First thing we have to fix. So k minus 3 over k plus 1 times 1 minus k squared over k squared minus 4k plus 3. Now we can't cancel anything here because everything's being added and subtracted. So we have to ask ourselves, can we make it or create a multiplication problem? So the bottom one we can change on the right one here. We can factor that, maybe we can't, but we'll have to find out. We get k, minus plus is a minus minus, factors of 3, it's factorable. And I'll look at 1 minus k squared. I'm going to rewrite that as negative k squared plus 1. That is almost a difference of 2 squares. If I take a negative 1 out, I will get k squared minus 1. And that is factorable. So I'm going to rewrite this as k minus 3 over k plus 1 times, I'm going to factor this. It's going to be negative, parenthesis, k plus 1, k minus 1, over k minus 3, k minus 1. Again, we changed the signs, which allowed us to make it something we could factor. Okay, well, we have k minus 3, k minus 3. Now remember, these are being multiplied. We have now a relationship that we can utilize and take advantage of. So k minus 1, k minus 1, k plus 1, k plus 1. What's left? Well, here's a 1, that's 1, this all is 1, and this is 1, but it's negative. Negative 1. Cool. Alright, the next one, notice it's already being times. So now it's just a matter of factoring if possible. X plus plus, factors of 6 that add up to 5, 3 and 2. The bottom one is a difference of 2 squares. Remember, see them on the street? Hello, you're a good friend, because these are easier to factor. Don't forget about these. And we cancel. We have the next, so basically, let's just do this. We changed this, so we're not going to look at that anymore. X plus 3, x plus 3, x minus 3, x minus 3, x plus 2, x plus 2. Didn't have to make any changes in signs, so one is our answer. Not always going to work out that nicely, but in this case, it did. Here ends Lesson 9.1, Part B.